Hello students, to part 2 of the exam review. This is question 4. The life of a particular battery is known to follow normal distribution with a mean of 1558 hours and a standard deviation of 144 hours. What percent of batteries last less than 1492? So in order to answer this question, I'm going to visualize first. Here is the normal distribution, and I know that the mean is 1558 and the standard deviation is 144. The first question asks, what percent of batteries less than 1492? So 1492 is approximately here. And I want to find the percent. Percent in normal distribution is basically the area under the curve to the left of a number, because this says less than. So this is particularly is the area under the curve, and it is to the left of 1492 because the question says less than that number. So that is the percentage, or the percent that I'm looking for. I know that to find that percent, I can use the function norm distribution, norm.distribution of the number 1492, comma the mean 1558, comma the standard deviation, comma true, because I need to cumulate all of that. It's always true for the normal distribution. So basically that is the answer for question number A. I'm going to do this norm dot distribution 1492, comma 1558, comma 144, comma true. So this is the answer. The next question, let me copy, and I'm going to go ahead and paste it over here. So that is the answer for the first part. For the second part, the 45th percentile is represented by what number of hours of battery life? We know that percentile is defined by the amount of data below it, not the amount of data above it. When we say below and above, we mean less than or greater than. So below means less than, and above means greater than. Here is an example. If this is the 25th percentile, that means 25% of the data is below that number and 75 is above it. So that is a clear example of how percentile works. In a normal distribution, it's essentially the same. So I'm going to erase this to illustrate what I want to say. So this one is the 45th percentile. So the percentile is basically defined by the area below it. So 45th percentile is the bottom 45%. So here is the bottom 45%. It's approximately here. This is 45% or 0.45. And I want to find that missing number right there. This is the number that represents that percentile, the 45th percentile. So to find the number that represents the 45th percentile, we're going to use the inverse function, since we do have the area to the left of a missing number and we need that number. This is part B, by the way. This is part B, but the number I called it C. Let me change that actually. Let me make it a B, so it makes a little bit more sense. So I can say here B equals norm dot inverse of the area to the left of that missing number, 0.45, comma the mean, 1558, comma the standard deviation. And that should answer the second part of the question. Norm inverse, 0.45, comma 1558, comma the standard deviation. And the answer is this one. I'm going to copy it and paste it there, just to make sure that the answer is correct. The last part, what is the probability that a randomly selected battery will last more than 1278? More than 1278. 1278 is, this is 1558. 1278 is approximately here. More than means above or to the right of. So this is all of the data that represents more than 1278, and I can't emphasize that enough, that the numbers at the bottom basically represent numbers, or that is a number line. And numbers are small here, and then they start getting bigger as we move to the right. The numbers at the bottom basically represent the battery lives in hours. So those numbers are basically the numbers that represent the battery lives in hours. So the probability is the area under the curve. And since it says here more than 1278, that means we want to find all of the area to the right of 1278, which represents the probability that the battery is going to last more than 1278. So to find the area to the right, we know that the function norm distribution does not compute the area to the right, but we know also that the area under the curve is equal to 1. So we're going to say that the area for C, part C, is equal to 1 minus norm distribution of 1278, comma, the mean, comma, the standard deviation, comma, true. The reason why is because 1, the entire thing, minus the area to the left, this area is going to be equal to the pink area, which is the area we are interested in. So I'm going to compute this really quickly here. So this is equal to 1 minus norm distribution of 1278, 158, 1558, 144, true. Next question, I'm going to use a similar question here. This week, a very large run-in race, the 5K, occurred in Denver. The times were normally distributed with a mean of 22.56 minutes and a standard deviation of 2.41 minutes. We want to report our answers to 2 decimal places. The first question asks, what percent of runners took 16.88 or less to complete the race? So the percent is the area under the curve. And here it says, what is the percent of runners that took 16.88 minutes or less? That means anything below 16.88 is part of the answer. To visualize that, here is the curve. So here is the curve. And the number of minutes is 22.56. That's the mean. The standard deviation is 2.41. 16.88 minutes or less. 16 is approximately here. So 16.88. I want to find the percent. So the percent is the area under the curve. This is the probability, equivalent to the probability. It's equivalent to the proportion, and etc. So 18 or 16.88 or less is this area right here. So that's what we're looking for. And notice that we have a percent here, simple, so we need to take care of that, and the answer needs to be reported in a percentage format. So to find the area to the left of a number in the normal distribution, we're going to use the norm distribution function of that number, comma, the mean, comma, the standard deviation, comma, true. So I'm going to compute that here. I'm going to say this is equal to norm dot distribution of 16.88, comma, 22.56, comma, 2.41, comma, true. And that is going to be the answer. Now to turn it into percentage, I'm going to go to the home and then go to this percentage sign right here. And then I need to round it to 2 decimal places. So I need to add 2 decimals, so it's 0.92. That is the percentage here, 0.92. And submit the question. The second part is asking what time in minutes. That means it's asking about the number at the bottom to find the number. And it has to give us a sort of an area to work with, an area under the curve or percentage or something like that. What time in minutes is the cutoff for the fastest 1.25? So think about it. This is a race. The fastest 1.25 is going to be at the bottom of the curve because the less time it takes the runners to finish the race, the faster they're going to be. And the smaller times are going to be at the bottom of this curve right here. So I can represent this in a picture like that. So this is the bottom 1.25%. Or if I want to report this as an area, this is 0.0125. Make sure you convert the percentage correctly. because if you make that mistake of saying this is 0.125, then your answer is going to be ridiculous. It's going to be like not even connected to the numbers that you see here at the bottom, but it has to be relevant to the numbers at the bottom. I have the mean and the standard deviation. I need this number right here. I'm going to call this number B, since this is part B. I need this number at the bottom, and I am giving the area to the left. That's all I need for the inverse function. So I'm going to use the norm inverse function, norm.inverse function of 0.0125, which is the area to the left. I never work with percentages. You always have to convert your percentages into decimals to work with them. And then the mean is 22.56. The standard deviation is 2.41, comma, true. It might be a good idea just to type the mean and the standard deviation in cells and use them instead. So I'm gonna do that. The mean is equal to 22.56, and the standard deviation is equal to 2.41. Now I'm gonna use these numbers. Equals norm inverse of 0.0125, comma, the mean. I'm going to click on the mean, comma, the standard deviation. I'm going to click on the standard deviation, and then comma, there is no comma, true. Okay, so that is the number. That makes sense. The number is less than the mean, as I expected. It's 17.15 minutes, approximately. 17.15 minutes. There we go. And we need to round that to 2 decimals, so it's going to be 16. On Excel, you're just going to click on it, go to the home button, and then you're going to decrease the decimals until you have your desired number of decimals. Okay, and the last part, what percent of runners took more than 1574? So again, we're asking about percentage. That means we're asking about the area. And since it's more than 1574, that means it's the area to the right of 1574. So here is the curve. 15.74 is less than the mean. The mean is 22.56, so it's approximately here. More than means anything above it or to the right of it. So this entire area that I'm looking for, this is the area right here. Now, to find this area right here, I can't use the norm distribution function right away, because that only computes the area to the left. But I can use it still, because I know the entire area under the curve is equal to 1. And if I subtract the area to the left, which is this one, the area to the left of 1574, I'm going to get the area to the right. So norm dot distribution of 1574, comma 22.56, comma 2.41, comma true. I'm going to use T for true, just for shorts. And then 1 minus norm dot distribution, sorry, of the number 1574, comma the mean. I'm going to click on the mean, comma the standard deviation. This one, and then comma true. And that is the answer. Again, the answer needs to be reported in percentage form, rounded to 2 decimals. So I'm going to click on the percent first, and then I'm going to increase the decimals twice. So this is more accurate, 99.77. So the answer here is 99.77. And that appears to be correct. Question number 6. In her Math 135 class, Professor Alaya found that the mean score of the first exam was 74. Suppose that the scores are normally distributed with a standard deviation of 18 points. What is the probability that a randomly selected score is less than 58? So here I can graph or I can visualize the area here. I'm looking at the score of 58, and I want to find the probability that a selected grade is going to be less than that. I know that the probability is the area under the curve because it's less than 58. That means the area to the left of 58 that is below the curve, the normal curve for the grades. The mean is 74. The standard deviation is 18. I find the area to the left using norm distribution of the grade, comma 74, the mean, comma the standard deviation, comma true. So this is a straightforward process. I'm going to compute it right here. Norm dot distribution of 58, comma the mean 74, comma the standard deviation. Let me actually click on the cells. That's better. Standard deviation, comma true. So that is the answer. And I don't think I need to report it as a decimal because it's a probability. So I'm just going to copy and paste. The second question, what is the probability that a randomly selected score is more than 78? So now more than 78, 78 is approximately here. It's slightly bigger than the mean. So here is more than 78, the probability of more than 78. More than means I need to find the area to the right, but the function does not compute the area to the right. But it can still find it because basically the area to the right is equal to 1 minus the area to the left. So 1 minus norm distribution of 78, 74, 18, true is going to give me the right answer. And 1 minus norm distribution of 78, the mean, I'm going to click on the mean, the standard deviation, I'm going to click on the standard deviation, true, double click here, and that is the answer. I'm just going to copy that and paste it into my answer box. All right, the last one is, what is the probability that a randomly selected score is between 58 and 78? The area between 58 and 78 represents 58 here and 78 here, represents this area right here. We can use the norm distribution function in order to compute that. Basically, if we find the area to the left of 78 using norm distribution, which is this formula exactly, then we can subtract the area to the left of 58 using a similar formula. Then we're going to end up with the pink area only. So that's what I'm going to do right here. I'm going to say this is equal to norm distribution of the bigger number, 78, the mean, the standard deviation, true, close the parentheses, minus norm distribution. Again, I'm going to compute the area to the left of 58, 74, 18, true. So I found the area to the left of 78 and subtracted the area to the left of 58 to find the area in between. And this is exactly the answer that I'm looking for. So you can customize these formulas. You can say, well, if I want the area to the left of a number, then I'm going to use norm distribution. If I want the area to the right of the number, that is 1 minus norm distribution. If I want to find the area in between, that is norm distribution of the big number minus norm distribution of the small number, mean, standard deviation, true. So you can write these formulas as formulas and then customize them with the specific numbers that you have. If you're given the area to the left of the number and the number is missing itself, then you're going to use the norm inverse function. If you're given the area to the right of the number, missing number, and you need that missing number, first you need to figure out the area to the left, and then you can answer the question afterwards. There is no such thing as 1 minus norm inverse. That is not a thing, so remember that. Question 7, for a standard normal distribution, so this is the first piece of information I have, find C. And then the second piece of information gives me the probability that Z is less than C is equal to 0.7702. So for this type of question, first I would like to create a graph and visualize my information and list all of the facts that I know. And then from there, I can use the appropriate function to answer this question. So the first piece of information I know is that the distribution is going to be a standard normal distribution. What does that mean? That means that the mean is equal to 0 and the standard deviation is equal to 1. So this is the first piece of information, and I can tell because I have a z-score here. The numbers at the bottom of the curve, all of these are z-scores. They are going to be positive on this side and negative on this side. Anything below 0 is negative. Anything above 0 is positive. So that is what I have so far. Now, I want to graph this area. It says here the probability. So I know that I'm graphing an area that Z, which is the z-score, is less than a certain number C. And the area here is 0.7702 or approximately 77%. So I know that the area is going to be bigger than half of the graph, for sure, because it's approximately 77%. And that this area is actually less than the C, the missing number C at the bottom here. So less than means it's the area to the left. To know the less than and greater than, less than is similar to the letter L, greater than is the opposite of that. So this is less than, and this is greater than. All right, now, all we need is here. We have the mean, we have the standard deviation, and we have the area, which is 0.7702. And we can find C using the inverse function. So C is equal to the norm inverse function of 0.7702, comma, the mean, comma, the standard deviation. This is if you're using the regular one. If you're using the specific formula for the standard normal distribution, you're going to use the one with an S in the middle with 0.7702, and you don't need to add anything else. So either one is going to work. Let me prove it for you. So this is norm inverse 0.7702, comma 0, comma 1, and this is norm dot S dot inverse of 0.7702. So as you can see, both of these are identical and they are going to be accurate. So that's what I expected. I expected the z-score result is going to be positive because the area is greater than half of the graph. It's not below 0, it's above 0. And because this is less than. So that's how you answer this question. The following question is dealing with the empirical rule. You can watch the video here to understand what that means. But I know that I'm not going to use the normal distribution here because it says the approximate percentage. It does not tell me to find the accurate percentage or the exact percentage. The empirical rule works only if we have the numbers that we're looking for, or the areas in between those numbers, if they happen to be whole standard deviations away from the mean. Like 91 is 1 standard deviation away from the mean, 107 is 2 standard deviation away from the mean, and 122 is 3 standard deviations of the mean. So that's, I can use the empirical rule. But if these numbers, let's say if I was looking for the number 77 here, and I want to find the probability that a student scored less than 73, maybe, then 73 is not 1 standard deviation above the mean, and as a result, I can't use the empirical rule here. I have to resort to the normal distribution. So this is just a link between the two. Know that the empirical rule is accurate enough, but it's not as precise as the normal distribution. So I'm going to answer maybe one question out of these, and then I will let you answer the rest on your own. So the first thing when you see the empirical rule is to put the percentages that we talked about before. We know that 68% of the data lies within 1 standard deviation of the mean. So if you break it down, that is 34%, and this is 34%. And then 95% of the data lies within 2 standard deviations of the mean. So if you do the math, you're going to say this is 13.5%, and this is 13.5%. And then 99.7% of the data lies within 3 standard deviations of the mean. If you do the math, you'll find this to be 2.35%, and this is 2.35%. And then the tail is 0.15%, 0.15%. Please don't forget the tail. I'm going to answer the second question. What is the approximate percentage students who score between 62 and 92? 62 is here. 92 is here, so I'm looking for the area in between. That is basically the probability that I'm looking for. It's the area under the curve between those two numbers. And according to the empirical rule, it says it is the 34% plus 34%, which makes it into 68%. So this is 68% is the answer. Let's answer this question. So what is the approximate percentage? Again, it's approximate percentage of students who scored higher than 122. Higher than 122, this is the area higher than 122. It's anything above 122. And according to the empirical rule, this is basically 0.15%. So 0.15% is the answer for the first part. Now, let me show you how to answer this using the normal distribution. If I'm using the mean here, which is 77, and the standard deviation of 15, then I can find the area to the right of 121 by saying this is 1 minus norm distribution of 122, comma, the mean, which is 77, comma, the standard deviation, which is 15, comma, true. And that is going to give me this number. I'm going to turn it into percentage. So percentage, and then I'm going to add 2 decimals to make it more accurate. So this is using the normal distribution, and it's slightly less than the approximate amount that is computed using the empirical rule. That gives me an idea that the empirical rule is accurate enough, but it's not too accurate, because the normal distribution, that is the most accurate calculation for this type of information. The second one, I can use norm distribution of the bigger number, 92, comma, the mean 77, comma, the standard deviation 15, comma, true, minus the small number, norm distribution of the smaller number, which is 62, comma, the mean. The mean is 77, the standard deviation is 15, and comma, true. I'm going to close the parentheses and enter, and then turn this into percentage, and then add 2 decimals to make it a little bit more accurate. As you can see, it's approximately the same calculations, but because I just made it a little bit more accurate, it was 68.27. So the empirical rule, as you can say, it works just fine to find the approximate percentage. If you want to find the exact percentage, then you're going to resort to using the normal distribution, the way we used it before. In this question, we want to find the z-score for the given shaded region under the standard normal distribution, and we want to round our answer to 2 decimals. So I'm given the area to the left of a certain number, and that certainly isn't 2. That isn't at 2. It's slightly bigger than 2. The area here is 0.98, and I want to find that missing number. So the first thing I notice is the numbers at the bottom are z-scores, and the answer required is a z-score. That means this is the standard normal distribution. So the mean is 0 and the standard deviation is 1. So that is the first observation I made. Then I know that if I was given the area to the left of a missing number and I would like to find that missing number, then I will use the norm inverse function. So that's what I'm going to use right here. So here is what I know. This is missing z-score. Let's say this is C. This is 0.98. And the mean is 0 and the standard deviation is 1, because this is the standard normal distribution. So I have everything I need for the inverse function. So norm inverse function of 0.98, comma, the mean, comma, the standard deviation. Or you can say C is equal to norm dot S dot inverse of 0.98. So either one is going to give you the right answer. I'm going to go with the second one, norm dot S dot inverse of 0.98. And that is the z-score. I'm going to round it to 2 decimals, just like the question suggests. So it's 0.05. This is not 0.05, it's 2.05. Okay, so it's 2.05, and that makes sense since the picture shows me that the answer should be a little bit bigger than 2. Thanks for watching. I'll show you how to answer the rest of the questions in part 3.